Thank you. So hopefully by the end of this talk, you will know why you haven't seen this combination before, okay? But first, let me just jump in to tell a few words about me. So again, my name is Péter. I'm from Hungary. I have a PhD in computer science, and I did actually work in the field of networking. So I have an unusually deep knowledge about networks, how they work. And I'm also a part-time assistant professor at the other university in Budapest called Eötvös Loránd University. But in the meantime, we also founded a company who created this tool called Stunner. And in the end, I will let you know what Stunner is, but it's basically a way to do WebRTC in Kubernetes. And I've been working with various cloud-native technologies for like 7 or 8 years now. So let's jump in. Like what WebRTC? Does anyone used WebRTC before? Or, okay, oh, wow, that's great. Cool. And by the way, I think everyone is using WebRTC all the time, right? Because that's just the protocol behind all these meeting tools like Teams, Meet, and Zoom. So all is using WebRTC because it's the way, the name is actually, like web real-time communication. So it is how you do real-time audio and video with your browser or any mobile app basically uses WebRTC these days. It's been invented by Google around, like 2010-ish, but now it's an actual IETF standard. So, everyone is interoperable and stuff. And it's built into all browsers, not just Chrome and the Chrome copies, but like, Firefox has the implementation and Safari as well. So because of its, standardized and very easy to use, so we always joke about this, that you can make a video call with like 3 lines of JavaScript in your browser. That's why people, starting to use it. And not just, like regular meetings. There are other like, audio video use cases that uses WebRTC. So like if you call a call centers, although, like the first part is a classic voice over IP call, but usually your operator picks up in a browser, and then that part is WebRTC. There are specialized apps for like EdTech or telehealth and so on. But since I think a few years now, there's a lot of other use cases emerging. So like remote rendering is a thing. So like rendering 3D objects and then stream down with WebRTC to your browser. We see a couple of weird use cases for like high frequency trading to, like stream arbitrary data with WebRTC because it's, was designed for this kind of real-time use cases. And now, voice AI is a thing. So OpenAI has a WebRTC interface that you can use to connect to like a GPT-o Omni model, and then like just talk to it. And now they use WebRTC. Before that it was WebSocket, and that was just a failure. So because how hard is to do real-time communication. So why is it that WebRTC is not easy in Kubernetes? So first, WebRTC is just like anything else. There's a quite large open source ecosystem around it. There are like so-called turnkey solutions, like media servers. You can like basically it's almost like a Google Meet copy. You can just deploy it and then use the API, and that's it. There are also neat frameworks, mostly in like this Pion is in Go, very, very popular. The other one, Media Soup, is in JavaScript. You can just, start building your own custom solution. And then obviously you can just grab them and put it into a Docker container. But if you're in the WebRTC world, you can find these blogs. So this is bloggeek.me, one of the most popular blogs in the WebRTC world. Just, a recent blog post that, like how do you start with WebRTC? And then one of the section has this title, Don't Use Docker. And so they don't like it. And the reason that they don't like it is, how WebRTC was designed and how the networking part of WebRTC is designed. So, it's always about networking, storage, or security that you have troubles. This time it's networking. Because the networking in WebRTC is fundamentally peer-to-peer. So you will always talk to one peer, and then your peer will talk you back directly. So that's a very weird case. And if you call your colleague on Microsoft Teams, you will actually see that you're directly talking to your colleague's IP and then back. So it's pretty interesting that it was, again, designed for peer-to-peer. Now, obviously, if you jump into a group call, talking to peer-to-peer for any other user in this WebRTC session is unfeasible, not just because, it's the full mesh looks insane and there's other problems with it. So anytime you have, like a group call with actually at least 3 person in it. You will go through a so-called media server. So that's one of the key elements in a WebRTC architecture. So like you will always send your audio and video to the media server and grab any other, participant audio and video from the media server. So it's a more scalable solution. There's actually multiple ways to do this. The old way was called the MCU. It just means that, that server will mix up the video and the audio for everyone, and then you just download one common video. But the more like popular ones are actually using this SFU model, which is just a dump forwarder. So like they collect everyone's. The media server do not touch, these streams. They just like forward it and multiplex these streams. So that's just a thing. But still, the important point is that the protocol is the same. So no matter if you as a user from your Chrome talk to someone else's Chrome or a media server, the protocol is the same. So how a call is built up between a user and a media server is the same if you were calling another user. So that's why I'm going to focus on this use case as well. And this is why it's actually very weird. So this is how a call is built up. You as a user and the media server on the other side will choose a random UDP port. And I hope you get the feeling that communicating via a random UDP port is not really cloud native, and that's going to cause all the problems out there. And you can't really influence this behavior. I mean, you can just like shrink down this port range that you will choose these ports, but it's fundamentally random. And then there is no session information in a WebRTC protocol on it. You will directly correlate a stream to a user, to your peer, based on these port numbers, and then that's it. Now, but how can you connect to a random UDP port? There's another element in a WebRTC architecture called the signaling server. Basically, you upload this information in this format called SDP, which is a very ugly text-based descriptor that contains a lot of information about how you want to handle this call. And then one of the information is this random port number. Okay, so there are other things like codecs you want to use and encryption keys, because it's actually peer-to-peer encrypted with DTLS. DTLS is just TLS over UDP. So, but one of the key information is, okay, I opened this port for you, basically. So you upload this, and then your peer downloads this port information in this SDP, and then you just try to connect, okay? I'm going to try to connect this random IP and port. And then I trust that you can see this, that this will, no way this works unless you are both on the public internet, right? And then, a media server can be on the public internet. And frankly, most of the WebRTC architectures that are out there now, it's on directly on the public internet, because otherwise this is going to be very, very complicated. But you as a user, you're never on the public internet. So we need to solve this problem. And that's where some funky protocols come into the place, which been out there for many, many years, but I don't know if you ever heard about it. At least I was not hearing about this until I joined my colleague in this company. And the first one is stun protocol. So again, the problem is that, this is a more usual scenario. So you, working from home, you're behind a home router, you have a private IP, and then the media server sits on a cloud provider behind some sort of like cloud net, but it's also on a VPC, so it has a private IP. So like one thing you can do with this stun protocol, it's very, very interesting, is that you can send it's one packet query, like tell me my public IP and the port you can see me, and it will just answer, okay, your public IP is this, and the port, usually, there is net between, so it will be a different port, but this is the port that I see this. So this is very, very similar if you go to like type in whatismyip.com. It's just instead of your public IP, you get your port number as well. But not just that. That's a very crazy thing that, because this is a standardized protocol for 20 years, you can have these net devices or routers, whatever, to leave that port open. And so you will actually also upload this information. We call this the server reflexive candidate. That's the WebRTC term, but it's not important. So this public port and IP And then your peer can try to connect to this port as well. So the public IP and the public port. And then if your router is set up in the correct way, or actually it's the default settings on any residential router, it will actually forward this traffic to you. So it's pretty crazy. I've never heard about this, and then you can do this. Stun is used outside of WebRTC, so again, it's not tied to WebRTC. So if you use any like peer-to-peer VPN, WireGuard-based stuff, which is very popular these days, like Tailscale does the same. So this is how Tailscale can actually connect peer-to-peer with stun protocol. So this is very cool. And it's actually usually works. Again, if you are doing home office and call your colleagues on Teams, this is how you can actually hook up your traffic peer-to-peer. And it's also mostly working on cloud in simple setups as well. But the problem is that I trust that if you have heard about security a lot, that if you're on an enterprise network, no way this is allowed. Yeah. So on the user side, and if you dig up even more your media server into a Kubernetes, it usually does not work as well. I will tell a little bit more about this on a later side. So that's a huge problem. Is this stun? Although again, many times it can work. In many cases, just flat out blocked due to security reasons. So what can we do then? There's another funky protocol called Turn, and Turn is basically a relay server that you can send all of the traffic through, and then you try to circumvent these net devices. So again, if I go back, Stun it does not send so it does not flow through traffic. It's just one query: what is my IP port, and one answer. But the audio and video goes peer-to-peer as well. Turn, you will send your audio and video through the Turn server. So that's how you circumvent these devices. And it's really working essentially quite same as if you use SSH tunneling. So it's like a tunneling protocol, but it's just overly complicated because it's it's an IATF standard. So there's a lot of stuff you can do. But basically you can use in two modes. You open a Turn tunnel to the Turn server, and then you will ask the Turn server to forward your traffic to a given IPM port. So you can ask the Turn server, okay, I know the IPM port that I want to connect to my media server. That's the random stuff. And if the Turn server can reach it, you're good to go. So that's, again, almost as the same as SSH tunneling. And just as SSH, you have a reverse tunnel mode. So I can ask the Turn server to open a port on the Turn server, and the Turn server itself can be on the public internet. And again, most of the public Turn servers are on the public internet, and then my peer can try to join, connect to this public IPM port, and then the Turn server will just reverse tunnel back to this to my IPM port. So this is how you can circumvent these net devices. And in most of the cases, you can do this, also open a tunnel and then connect to the reverse tunnel as well. So this is how you circumvent all the net devices on the that you're behind. So that's pretty cool because and again you can send all this information in this SDP as well. So your peer can try this. And so the cool thing is that this will almost always work. So again, and it's just like SSH. It's tied to one port as well. So it's actually tied to one port per protocol because you can use Turn over UDP, over TCP, or over TLS and DTLS. So the port is your choice. And the way usually people use it is that they open it on TLS 443 so that the firewall thinks that it's HTTPS. So they will let it through, unless you have something very, very restrictive environment. So that's cool. The problem is that now you flow all the traffic through the Turn server, so that can add latency. And then obviously, if you use TLS 443, tunneling a fundamentally real-time UDP traffic in a TCP tunnel, not the best idea. But then again, it is better that you actually have connection, and sometimes the connection is bad rather than not having a connection. So the key thing here is that even in current WebRTC deployments, because users can be behind a restrictive firewall, about like 10-20% of every WebRTC follow, let's say, uses a turn server due to a restrictive firewall. So no matter what you do in your WebRTC deployment, you will need a turn server to solve this problem. And then let's jump to the and then all this process where you open the port and then gather these candidates, your like normal open ports and this ton reflexive candidate and this like open reverse tunnel return, and then try all these connections. It's called ICE. It's just, if you hear this term, this is the ICE process. How you like collecting this IP port pairs and then send it over and then try to connect to your peer. So jumping on the other side, like Kubernetes. I will just jog this through. So, how a Kubernetes cluster usually works is that you have nodes, worker nodes. They have a private IP most of the time. They may or may not have a public IP, depending on whether you use a public or a private cluster. Pods have their own virtual, IP subnet. Usually like having a /24 subnet per node. And then we use services. Cluster IPs, have their own public virtual IP, private virtual IP space, and then you can have a load balancer type service where you get a load balancer with a public IP from your cloud provider, and then a user can try to join this pod. Okay, and then the problem here is that you will go through so many layers of net. You will not be able to solve this kind of like how can I connect to a random UDP port in a pod? This is just like, you can try to build something, but I don't think it will work. And then the other problem is that usually because you go through so many layers of net, you can try this stun protocol, and then very surprisingly, sometimes stun goes through, but most of the cases it will be blocked by one of the layers. And it's just dependent on the CNI, your queue proxy mode, your load balancer providers, so many things. It just depends on. Usually you can rely on. So what can you do in Kubernetes? So the first thing you can do, and that's most of the people we met in the WebRTC world are doing, if they use Kubernetes, is just run these media servers in host networking mode. So in host networking, rather than a pod having an IP from this like pods virtual network, they bind their networking to the worker node, and if that's a public cluster, and usually they will use a public cluster for it, they can advertise the address of the node itself, the public IP, and that way, and then you just allow this random UDP ports, that this huge UDP port range in your firewall, you can connect via this public IP and the random port. So again, this is how most of the deployment works, I believe, for those companies who use Kubernetes. But if you use Kubernetes enough, you know that, you shouldn't really use host networking. It introduces so many problems. So you're going to have a hard time to just upgrade these pods because they can't run on the same node at the same time due to port conflicts. And in case of WebRTC, because sessions are very long, you're gonna have maybe you wanna leave those pods running for hours after termination, just to not terminate the current session on them. When you have a lot of load and you want to scale out, it's really hard because you want to scale out nodes first and then pods. It's just really slow and also very cumbersome to do. And then it's just a security nightmare. So again, because of how host networking and network security policies work in Kubernetes, it's just people really don't like this so much that in most enterprises you just can't do. There is a policy that will block you if you want to run a pod in host networking. So and then again, at the end of the day, you will also need a turn server. When the user is behind the firewall. So that's it. If you want to use a normal pod in Kubernetes for your media server, you want to have to use a turn server as well. And then just basically send the traffic through this turn server and circumvent this, many layers of net. And so the good thing is that there are a lot of providers. so you can buy it as a service from big companies like Cloudflare or Twilio, and there are a few other small providers. It's very easy to set up because it's essentially just a config with an IP or host name and some credentials. So you can add this to your configuration and you're good to go. The problem is, because Turn is a relay, you will send all the traffic through the Turn servers. It can introduce a lot of latency, which is, again, because it's real-time communication, sometimes it's bad. And then, if you have a WebRTC stuff, most of the cases it's video. Video generates a lot of traffic, and you're going to pay by gigabytes, and you're going to pay a lot by the gigabytes. Why? Because, I think Twilio also uses AWS, and then, the network cost in AWS is by itself large. So you're going to have to be very careful. But it's actually a good idea to start with this because, Turn is a standardized protocol, so you can just always switch this in your config. So the next thing is, obviously, there are a couple of open source Turn servers out there on GitHub. Most of the cases, this tool called CoTurn is one of the most famous one to use. So you can just actually start your own Turn servers. You can put them in the same region as your, like Kubernetes cluster is running, so that you don't have too much latency. And then you can do this. The problem is it is like really hard to do because you're going to have to take a lot of care about these Turn servers because essentially you're like relaying all the traffic now because how further you dig these media servers in Kubernetes. So most of the traffic will go through these Turn servers. If they go down, all your connections will go down. It's never a good idea. So building a highly scalable Turn server, architecture is really, really hard. And then you're going to have to deal with like, geo distribution because, if two like Australian people want to have a call, you never want to relay them through whatever US West, right? So that's actually a very hard problem. So, but then, this is what Kubernetes is for. Isn't Kubernetes for, like running these things like globally, multi-cluster, failover and stuff? Yes. So you can actually grab the Turn server and put it as a regular pod, open open them to the world with the load balancer. Again, Turn have fixed ports, so you can do that. And then if they are on a regular pod network, they can just reach the media servers on the regular Kubernetes network. So that is the way to go. Although, if you just grab any random Turn server and put it like this, you will need a couple of toolings so that, it's just high available and, secure enough. And then this is why we built Stunner. So Stunner is basically a Turn server, although it's funny because the name is Stunner. We do speak the stun because it's essentially part of the same protocol stack. But the magic happens in Turn. You can open these Turn tunnels and then publish them via any cloud load balancer. And it's purposefully built for Kubernetes, so all the tooling is around it. It's written in Go. It's based on this library I mentioned called Pion. And then you can configure it, via just, any other regular Kubernetes resource. This other stuff that, with the dotted arrow means that still your media server has to connect to the user. And again, most of the time it can connect directly back to the user using Stun. But if not, the user can open a reverse tunnel on Stunner, and then the media server can connect back. So, and then the great thing about it is, it's very easy to config, install, manage, because it's Kubernetes. And again, we purposefully built it for this. You can just use horizontal scalability. You can also use multi-cluster. As long as you have pod connectivity, it's okay to, open a Turn connection in one cluster. And then if that cluster, you can reach the other media servers, it will just work. One drawback is that, this Turn tunneling stuff costs a lot of CPU. So you're going to have some CPU load on this, but again, you can just start to horizontally scale Stunner, and that's it. So, and if you see this, it's essentially the same analogy that we use for like Ingress and an HTTP server. So we never really expose any HTTP-based web servers in our cluster. We use an Ingress to do that. Why? Because it's just easier to manage, it's more scalable, and so on. So much that, now we used Ingress a lot. It has its own limitation that they introduced the gateway API, which is just, you can call it as a next generation Ingress, the gateway. And we implemented Stunner so that it uses the gateway API. So we are actually a quote-unquote official gateway API implementors. We are listed on the gateway API side. So that's cool, because how this works, we really try to mimic the behavior how the folks build Envoy Gateway. That we have actually a Stunner operator. You can just install it, it's one Helm. And then you can create, like a couple of configuration that we have CRDs for. I'm not going to go through all this. It's just, it's Kubernetes, so a couple YAML files you have to just start. You create a gateway class that's, very similar to Ingress class. And then you create a gateway. That's when you specify the ports, that which one you want to listen. And in our case, you have to, state that whether it's turn UDP or turn TCP or turn TLS, or actually turn DTLS we also support, but nobody uses that, to be honest. But anyway, and then, if it's TLS, just attach a secret. That's it. And that will create the actual deployment of like Stunner, or as we call Stunner D, the actual daemon, the turn proxy daemon, and then create the load balancer services as well. You can have a lot of room to configure it. You don't actually have to use the load balancer. Some people use node ports because, actually load balancing with UDP is also a nightmare. So sometimes you can get into troubles of, how your cloud load balancer is handling UDP. So, and the final thing is that, because turn is essentially a tunnel, so if you can connect to a turn server, essentially you can send traffic to everywhere where that turn server can reach, which is also a huge security risk, right? So you want to be careful with that. In Stunner, we designed this that Stunner actually blocks every traffic by default, and then you have to explicitly allow those endpoints that you can send your traffic to, which is normally is just your media servers. So like you have to point this to your media server service, and that's it. And when you do that, users can actually connect there. So that's why we use UDP route, and that's the final thing. So again, with a couple of YAML files, I can tell this. I can start a Google Meet copy that like highly available, works really good in like 2 minutes in any Kubernetes now. So that's why it's good idea to use Stunner. So that's all. So again, this is why we created Stunner. I think we started this like 3 years ago. Many, I think, big companies using this right now, hooking through a lot of traffic through them. And then again, this just comes down to how WebRTC was designed with this very weird peer-to-peer connection setup with random UDP ports that you cannot really use in Kubernetes. But this turn protocol is a good way to build like this kind of like gateway service, and that's what Stunner can do. So that's all, and hopefully we have sometimes for a few questions.
I would have one.
Yeah.
So I didn't get completely how you solved the problem with the random ports and the case that my nodes don't have a public IP, so the host networking is also not an option.
Yeah.
So, and then I have a load balancer IP, and usually I have to tell like what port I want to use for that. So how do you do that?
Yeah. Again, so that's kind of like behind with this whole like signaling plane. So by the time the user opens this turn tunnel to Stunner via just a standard load balancer, again, that works. It knows because of the signaling plane, which is out of band, so usually uses HTTP with other servers and stuff. So it knows where to connect. So basically, it knows the pod IP and the random port of the media server that it opened. So it can ask a Stunner specifically to connect this pod IP and this random port.
Yeah, but does this random port has to be open all the time already?
No. The media server will open this just for that user. And then the way how the Kubernetes network works is actually, it's not blocked by default. Or yeah, well, you have to allow it with your security policy, but by default, you can connect between IP, you have all connections. So no matter what port is open, Stunner on the same pod network can reach that random port of the media server.
The load balancer has to support this feature, right?
No, because the turn tunnel is a fixed port. So you're tunneling, on a fixed port to Stunner, and then it will just like decapsulate that tunnel for your traffic and then send it through the Kubernetes network. I know it's pretty confusing, so it took me like 2 years to understand this because it's just really, really cumbersome how all this protocol works, but it does work. And then, this is the point. So other questions, yeah?
It's just a short question. The start protocol, does it use UPnP then for the web traversal for clients? Or?
I don't think it uses, just for the fact that I have no idea what UPnP is. So.
I thought that's the feature on the routers which opens automatically.
Oh, maybe it is, but I've never heard that term. So maybe that's under the hood. So I don't really know how they leave that port open, but they will leave that port open. So other questions maybe?
And it should be the last one also because we are running out of time.
Yeah. Yeah, you can use. However, there is one like caveat for this. So in many cases, you have so many layers of NAT that you will lose the user's public IP. So you have to set up the load balancer so that it is not do source NAT. And in many cases, you can do that, but you have to be very specific on your load balancer configuration to not do that. But yes, you can do.
Okay, so thank you for the talk.